Hi, team. Last time I told you that we were going to talk about PortalSIX for the next few weeks. PortalSIX is an entrant, a tech startup that I'm involved in, and it is going to address some of the biggest cybersecurity problems in information exchange. So today we're going to talk about one of the problems that PortalSIX addresses, and that's quantum computing. Quantum computing has got a lot of perils and pitfalls, and it's coming pretty soon to affect all of our lives. But the key question is, okay, so fine, but what is quantum computing anyway? First thing we're going to talk about is what is quantum computing? I think as everybody knows, computing since the beginning of time has dealt with zeros and ones. Something is either a zero or a one, and it's that back and forth, on and off, up and down oscillation that powers chips and computer programs and everything that we use from our phone to our laptop to, frankly, our car computer. So all modern computing has been based on zeros and ones. For quantum computing, a thing can be a zero or a one, or both at the same time, or any combination in between. And the ability for a quantum computer to have a zero and a one, or a zero and a one, or anything in between is called superposition. Okay, great. Why do we care about superposition? I'm going to take a little detour into talking about cryptography, because what we're talking about is cybersecurity, and security relies on cryptography. And specifically classical cryptography that relies on what we call a one-way function. And a function is one way if we can calculate the output very easily. 2 + 2 = 4. That's pretty easy. But if backtracking from the 4 to what produced it is hard. So if I told you the answer is 4, you would have no idea what got to the 4. Was it 0 + 4? Was it 2 + 2? Was it 1 + 3? Was it 2.5 + 1.5? Deriving that from just the number 4 would be really difficult for you. You'd have to spend a long time guessing. And that's why our current classical cryptography works so well, because all that guessing for your passwords and your encryption keys and all of that takes a long time. And so it's what we call computationally infeasible. It would take 10,000 to 100,000 years to break modern current classical cryptography. So that's good. That means our cryptography right now works just fine. Problem is, quantum computing increases computing power exponentially when it arrives with its attribute of superposition. So that means we've got a problem. And the problem is that all currently accepted standards of cryptography are going to break. And they're going to break pretty quickly and pretty much overnight when quantum computers come online. The US government predicts that cryptographically relevant, and that's a phrase for you, right? Cryptographically relevant, which means going to impact all cryptography that underlies the internet. Those computers are going to be available in 5 years. PortalSIX, an information exchange cybersecurity product, will address the quantum threat. So to give you guys an update, remember PortalSIX is a tech startup that I'm involved in. We have 50% of our seed funding secured, and we're still looking for visionary investors who are interested in going on this journey with us. So if you have interest in learning more about PortalSIX and perhaps becoming an investor, you could DM me or email me at amurray@emediaweb.com.